Distance on the coordinate plane. Okay, this is where we kind of put our big kid pants on. This is like one of those spots in our school year here in 8th grade where we're kind of dipping our toe into 9th grade algebra. So not complicated, just like one step further than what we've been doing. So we did this in 6th grade, finding the distance on the coordinate plane. Here's a point that I put in here. I put it in here at -3, -3. Right? And in 6th grade what we did was we just put another point on the coordinate plane and said, how far is it? And when we practiced that, we just did 1, 2, 3, 4, 5. So the distance for this, and we'll describe distance with the lowercase d, is say that's 5 away. Right? Now for 8th grade though, we're going to change it up a little bit. So I'm going to take that off, and I'm going to move that dot to here. Now, when we're finding the distance between these two, let me get my thing on there, and then draw my line. I'm finding the distance between those 2 points. Let's just make it a segment like that. What I can't do is I can't count now. So the coordinate plane, by law, the coordinate plane has to have these increments. They all have to be equal, but we don't have an increment for how it crosses it. So I can't be like, that's kind of 1, kind of 2, kind of 3. I can't count those off like that. So what we're going to do is we're going to make a right triangle out of it. And when we make a right triangle on it, then we're going to go back and use Pythagorean theorem. And a squared plus b squared equals c squared. And when we do that, what we'll find is we can then determine the length of that line, which is the hypotenuse of the right triangle that we created. So just to bare bones this right here, I would create a right triangle like that. We would figure out our legs by using our 6th grade skill of counting, and then using our 8th grade skill of the Pythagorean theorem to find the hypotenuse. Let's try this out. I've got 2 ordered pairs here. First thing I've got to do is graph them. I've got 1, 3, so 1 on my x. I walk to my elevator, then I ride my elevator. There's 1, 3. And -2, 4. Another walk to my elevator, and then 1, 2, 3, up 4. Kind of a short distance. I don't mind. Let's get a straight edge so we can put a line on that. Here we go, that's nice. Now, like I said, there's no way for us to count this because it's not traveling along the grid in a horizontal, or here, this goes here. It has magnets. We can't count it like that, but we can count it by creating that right triangle. So I'm just going to do the right triangle with dots right now. So I'm going to go doot, 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 and doot, 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 doot. Feel free to make the noises. It helps me. And then I know this is a right angle because I made it. Right? And now if we label this triangle, we can label this triangle with our A, our B, and our C. We can say that's side A, that's side B, that's side C. And now we're right back in our Pythagorean theorem mode. So I'm going to write my Pythagorean theorem over here. A squared plus b squared equals c squared. So I'm just counting now. And since we're counting distances, we're going to count them as positives. So the distance from here to here is 1. So that means I'm going to do 1 squared. Now, I can make it positive because even if it was negative, if we were deciding it was negative, and this goes back to kind of when we were counting for slope, even if it's negative, it's going to get erased because we're squaring it, because the negative times the negative makes it positive. So then this one is 1, 2, 3, plus 3 squared equals c squared. So I have a distance for A, 1. I have a distance for B, 3, and I don't know C. So now I'm just going into the math. 1 squared is 1. 3 squared is 9, equals C squared. 1 plus 9 gives us 10, equals C squared. Now we don't want C squared, we want C. So we take the square root. If we take the square root on one side, we have to take it on the other, which gives me C equals. Now my guess is, if we were back in first unit and estimating this, 9.1, 9.2, someplace in that area, clear out my calculator, second function x squared.
Hello, wonderful staff. Hey, this is just a reminder that the meeting's going to be starting real soon in the multi-purpose room.
Oh,
so if you're
it's
not there
Mrs.
at this
Pythagorean.
point, I would say
How
start
nice.
making your way over. Thank you.
We will. And what I get is 3.16. So if we're rounding to the nearest tenth, that 3.16 is approximately 3.2. And then that's the length of C. So the length of C in this case is 3.2 units because we don't have units on there. In math, we usually set up things so that we can do be the most correct with the least amount of work. And generally what that means is we start to set up formulas for things. And if we have a formula, then we have a reference point that we can go to that tool, get that out of our toolbox, and then solve a problem without having to do a lot of work. Now previously what we did is we had two ordered pairs and we put that on a coordinate plane and then we were able to draw the right triangle. In this case, we just have the two ordered pairs and we're not going to draw a triangle. They're completely out in space, totally abstract. We're not going to draw the legs of the right triangle. We're just going to use the formula. So on this slide, we're just going to show you this is the formula and this is how it works. So if I'm trying to find the distance between these two things, the formula starts with distance equals, and then we're going to start with the square root of. Okay, now we have to find the distance between the x's and the distances between the distance between the y's. And we do that by doing this. We're going to do x sub 1 minus x sub 2 minus x sub 1. I'm going to put those in parentheses. And then we're going to square it. And then we're going to add that to y sub 2 minus y sub 1. And then we're going to square that. Now, doing that, what we're doing is we're finding how far is this, and how far is this, and then take that and we're going to lay that on top of this idea of that Pythagorean theorem. So we got a squared plus b squared equals c squared. We know that the distance between these two, if we were to make a right triangle, is the hypotenuse. So we're trying to find c. So what we're doing is we're setting up an a here and squaring it, and a b here and squaring it. And then, like we did in the previous problems, at the end, we'll add the two together and then take the square root of those to get c. All right, in this problem, it would just be like this. So I'm going to just simply label this x sub, I'm going to make this one x sub 2. X sub 2, y sub 2. And I did that because these values are greater than those values. And this will be x sub 1 and y sub 1. So then this will look like d equals the square root of 5 minus 3. So parentheses, 5 minus 3 squared. Let's get some color in this so we can see it a little better. And then we're going to add that to our y's. So now we're going to subtract the y's from the y's. So 9 is 7 steps away from 2, but we're just going to write it as 9 minus 2 right now and then square it. We'll go down a level. We'll say the distance of that from between those 2 points is the square root of 5 minus 3 is 2. So I've got 2 squared plus 7 minus 2. 9 minus 2 is 7. I said the answer there in the question. Good job, me. 7 minus, I did it again. 9 minus 2 is 7. So I've got 7 squared here. And now I'm going to do the exponent underneath this. Don't forget, like this radical that we write here is a grouping symbol. So we're going to do what's underneath it first and work our way outward. And now we have d equals the square root of 4 plus 49. And then we have d equals the square root of 53. And now going back to first unit, we know 8 squared is 64, 7 squared is 49, which means this is going to be a little bit more than 7. To get a precise value on this, I'm going to hit second function, radical, 53, enter, and what I get is d equals 7.28, and then I'm going to say d is about 7.3. All right, that's how distance formula works. We're going to take the pieces of our ordered pair, and we're going to use the formula to do that. Let's do the same thing though, and let me show it to you in a conceptual way. So I'm going to flip this so I get a new board. Where's my new board? There's my new board. There we go. I don't know if you noticed, but nothing happened. So I'm just going to draw this so we can kind of conceptualize what's happening here. So let's put these 2 points out here in space. I've got 3, 2, and I'll just put a dot there. And 5, 9. So 5 is just going to be a little bit over, but 9 is pretty far up. So I'm going to put 5, 9 right there. 5, 9. Now what we're trying to find is this distance right here. So how far are those 2 points from each other? Now when we do this, this is where the formula comes from, is we're going to make a right triangle. And just to show that, I'm going to use some dots here. So let me get the red, and I'm going to go dot, 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 dot. That's about directly under that. And let's put that on there. Let's get the purple. Dot, 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 dot. That's pretty good. Okay, so we've made a right angle there. And then we're just looking at the expressions that we would write here. So in this side, we're looking at the vertical, right? We're going from 9 down to 2. So the length of this side is 9 minus 2. Now remember, when we're doing this, eventually we're going to square these values. So whether we make them negative or positive, it does not matter. And then the distance here, so now we're looking at the x's. So this is 3 on the x, this is 5 on the x. So I'm just going to write 5 minus 3. Okay, we've got 2 sides of our right triangle. So now I'm going to go back and let's look at Pythagorean theorem. A squared plus b squared equals c squared. We do not know c. So let's put our legs into this and say 9 minus 2 squared plus 5 minus 3 squared equals c squared. Now remember that formula. The formula looks like this. I'm going to put it down here. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? Now we have those x's and y's here. We have them squared here. And the only thing that could throw us off is that radical. Where does that radical come in? All right, so let's keep working on this one here. This gives me 7 squared plus 2 squared equals c squared. We did that with the formula too. 49 plus 4 equals c squared. 53 equals c squared. Now, we did all of that in the previous problem just under a radical. And now here's where that radical comes in, because we don't want c squared, we want c. So then we take the radical of both, and from that, where's my calculator? I get 7.28. 7.28. Same thing as the formula, but here conceptually we can kind of see why the formula works. We're just finding the distance between the x's, the 5 and the 3, the distance between the y's, the 9 and the 3. Yeah, 5 minus 3, sorry. And then applying, we're applying the Pythagorean theorem, but what we're doing is we're wrapping it all up in this nice little package for the formula. Okay? So, try using the formula. If it's not working for you, take a look and see if you can kind of conceptualize what that right triangle looks like. Good luck.